At 25 degrees Celsius, the molar conductances at infinite dilution for the strong electrolytes NaOH, NaCl, BaCl2 are given. They are asking to calculate lambda m naught value of BaOH twice. Here NaCl is having two common ions. Na is a common ion with respect to NaOH. Cl is a common ion with respect to BaCl2. So to calculate lambda m naught value of BaOH twice, we need to subtract lambda m naught value of NaCl from lambda m naught value of NaOH and BaCl2, and we need to multiply NaOH and NaCl lambda m naught values with 2. Why we need to multiply? First of all, the formula lambda m naught of BaOH twice is equal to 2 into lambda m naught value of NaOH plus lambda m naught of BaCl2 minus 2 into lambda m naught value of NaCl. Why we are multiplying NaCl and NaOH with 2? If we split that into ionic form, we'll understand. 2 into lambda naught of Na plus 2 into lambda naught of the OH minus. Similarly, we can write for BaCl2 also lambda naught of the Ba plus 2. 2 Cl minus ions are there, so 2 into lambda naught of the Cl minus 2 into lambda naught of the Na plus minus 2 into lambda naught of the Cl minus. Na plus we can cancel, Cl minus also we can cancel. What is remaining here? Lambda naught of the Ba plus 2 into lambda naught of the OH minus. So we are getting lambda m naught value for BaOH twice. So now given value, substitute in this formula. Lambda m naught value BaOH twice is equal to 2 into lambda m naught value for NaOH is 248 into 10 power minus 4 plus lambda m naught value of BaCl2 is 280 into 10 power minus 4 minus 2 into lambda m naught value of NaCl is 126 into 10 power minus 4. So 2 into 248 is 496 plus 280 minus 2 into 126 is 252 into 10 power minus 4. So we'll get the value 524 into 10 power minus 4 Simon meter square mole inverse. So the answer is option B.